Hello class. Today I will be doing a test of independent frequencies by hand. This test is used to compare the frequencies of different responses when each response comes from a different subject. In this example problem, we have just conducted a poll to see whether people prefer Oreos, vanilla wafers, or animal crackers. What we want to know is whether there is a difference in the number of people preferring the three types of cookie at an alpha level of 0.05. Before we begin, we need to make sure that we have a separate row for each of the types of cookies. Each of these rows is referred to as a bin. Each bin is a possible category that a person could have voted for. The number of bins will be important for our calculations. We will also need a place to write the total number of votes. And we will need a column for the actual number of votes, and a column for the expected number of votes. The first step is to calculate f sub e, which stands for the expected frequency. The formula is on your screen. The expected frequency is the number of votes that we would expect to see if people did not have different preferences for these types of cookies. In other words, we want to know how many votes each type of cookie would have received if the votes had been evenly split between all three of them. In order to calculate f sub e, we need to know how many total observations there were, as well as how many bins there were. Our total number of observations is equal to all three bins of votes added together. And we have three bins because there were three different cookies. Our f sub e is therefore equal to 953 divided by 3, or 317.67. We can write this expected frequency for each of our bins, like so. Next, we need to find chi-square. The formula for chi-square is on your screen. In order to calculate chi-square, we need to use the f sub 0 and the f sub e for each of the three different bins. F sub o stands for observed frequency, which refers to the number of votes that each of the bins actually received. As we already know, f sub e refers to the expected frequency for each of the bins, or how many votes we would have expected each bin to get if there wasn't a difference in preference. You'll need to write out equations for each of the bins and then sum them together, like this. So each one of the bins gets its own formula, like you can see on your screen up there, where you take the observed minus the expected squared, all divided by the expected. And then what happens is, what that fancy symbol up there means, is that you add all three of those bins together. Once you have your chi-square obtained, you need to find your degrees of freedom. This is equal to the number of bins minus 1. In this case, our df is 2. Next, find chi-square crit. To find this, consult the chi-square table and find the value tied to your degrees of freedom. In this case, a df of 2 corresponds to a value of 5.991. Compare chi-square obtained to chi-square crit. In our case, our obtained value is greater than the critical value, which means that p is less than 0.05. And we have found a reliable difference. Finally, we can write our conclusion. The data show that the number of people preferring Oreos, vanilla wafers, and animal crackers is reliably different.